Hello, this is Jeff Hamrick at the University of San Francisco's Master of Science in Financial Analysis program. I'm going to talk for a couple of minutes about using the ArchLM test to try to determine what an appropriate order might be for an arch specification in a volatility clustering model. So what I've got here is some heart rate data. The heart rate is measured every half second. I've created a dummy time variable in Stata and declared this to be a time series data set. And if we use the tsLine command, we can take a look at what this time series looks like. It's not necessarily evident per se that there's any volatility clustering in heart rate data, but there might be if we use something other than visual inspection, like the ArchLM test, to try to make this determination. So what I'm going to do is the following. I'm going to first fit some sort of ARIMA model to this data. And what I've determined already before the start of the screencast is that an Arch2 model is a very good fit for these data. So I'm going to use the ARIMA command to fit to the heart rate data an AR model of order 2. So Stata uses maximum likelihood estimation to fit an AR2 model to these data, and we end up with this time series output. And I'm going to then extract the residuals from this model and see if an arch specification might be productive in this particular instance. So what I'll do is use the predict command and create a variable called myResiduals that is the residuals from the prediction in sample for this particular time series data set. So there the variable is created right here. It's the one-step forecast within the sample, and we can even look at the time series plot of the in-sample residuals. And it's not necessarily obvious, again, that there's volatility clustering in this data set. There's certainly some odd spikes in this data set, in the residuals, that is the noise not accounted for by the AR model of order 2. But let's go on ahead and run the ArchLM test to see if an ArchLM specification might be appropriate in this case. So what I'm going to do is regress the residuals against nothing in particular. That is to say, I need to use the regress command to then use the estat ArchLM invocation. And I don't have any independent variables in mind to predict the residuals from my AR model, so I'm just going to regress residuals against nothing, that is, to fit a constant to them, and then effectively the residuals from this regression will just be the d-mean version of my residuals, which is going to be pretty close to 0 in most instances anyway. So once I run this, I can then invoke the ArchLM test in Stata, and what I'm going to do is I'm going to explore lags, let's say 1 through 15. I'm making that determination kind of arbitrarily, but usually if there are significant arch effects beyond lag 15, it's almost certainly going to be the case that you want to move to a Garch type specification anyway. And so I don't know that we, practically speaking, need to consider more lags than this. So what we're looking for here is large jumps in the chi-squared statistic. And of course, going from 0 lags, that is no arch specification, to 1 lag, we see a big jump from 0 to 37.977. So certainly there seems to be some type of arch effect, at least of lag 1. And then this jump from 37 to 40 is not necessarily small either. If you wanted to quantify that, you would do that in the following way. You would say that the difference between this chi-squared statistic and this chi-squared statistic is another chi-squared statistic of degree of freedom 1, and you could determine the difference between those two. So I could say display the difference between 40.304 minus 37.977. That's 2.327, and this is an approximate consideration only. But you could then say display the chi-2 tail, the chi-squared tail, for a chi-squared distribution of degrees of freedom 1 at the threshold 2.37327. And that p-value is not particularly small, therefore we don't have a lot of evidence of arch effects of order 2. We might have enough evidence for arch effects of order 2 if we're kind of generous with our significance threshold. But certainly when we look at the way that the ArchLM test, when we nest it going from lags 2 to lags 15, there's barely any increase whatsoever. So I'm not sure that arch effects, an arch specification of lag greater than 2 is appropriate in this case. So I might conclude that what we need is an arch specification on the error terms, let's say of just order 1 or order 2. So how might we investigate how we might do that fit in Stata? Well, we use the arch command. And so what I'm going to say is let's fit an arch command to heart rate, and let the base model be an AR model with 2 coefficients, but let's add an arch specification on the error term, first of order 1. Let's check this out. So Stata uses maximum likelihood estimation again, and we see that we have a statistically significant coefficient on the lag1 arch term. This might be a better model than the first model, that is an ARMA model with just 2 autoregressive coefficients. What about the idea of using an arch specification with 2 lags? Well, to check that out, let me call this back up and change this option to 1/2. And what I see in this particular case is that we get 2 significant coefficients, so we might want to consider having an arch specification of order 2 on the error terms, and letting the level of the time series, that is the raw heart rate data, be modeled by an AR process of order 2. So this is how you use the ArchLM test to kind of feel out what the order of the arch specification should be. If the order of the arch specification is very, very large, you might want to consider using a Garch term along with the arch terms that you choose. Usually adding a Garch term allows you to drastically reduce the number of arch terms that you consider using in your model of the variance. So that, in brief, is how you can use the ArchLM test in Stata to investigate what might be useful arch orders for an arch specification on the error term. Thanks, and let me know if you have any questions.